I've clicked onto the Global Tropical Review for August the 5th or 6th in the West Pacific 2023. As is always the case in these videos, the thoughts expressed are mine alone, and when making decisions ahead of any tropical cyclones, look towards your local weather office, local emergency management, and local tropical cyclone warning center. We're going to be talking about a lot today. We're going to start off with current things in the tropics with Khanun, Dora, and Eugene in the Pacific. And then after that, we'll be talking about some information on the Atlantic hurricane season and what we can expect over the coming months as we go through the peak of hurricane season, as that has really piqued my interest this year. And I'll leave chapters in the description below so you can see exactly what you want to go to and not have to sit through a bunch of my discussion. Now here is Tropical Storm Khanun, which is still near Japan. I haven't had a video all week, and I apologize for that, but you can see it is still over the Japanese islands, but it is also looking much, much worse than it did when I last made my video. You can see the center pretty much is exposed completely here with some convection on the southwest side of the center. And this is a factor of it sitting over the same region pretty much for the past week overall. And you can see that there has been significant upwelling here because there really was not much oceanic heat content here. And you can see it's actually upwelled waters cooler than 26 Celsius, which is pretty cold for a tropical cyclone. Now, the system is tracking now a bit quicker, and it will be reaching an area of warmer sea surface temperatures of 28 to 29 degrees Celsius. And given conditions, it will likely be able to re-intensify a little bit and may become a typhoon before it comes into Japan and heads further north. And then after it comes further north, that will likely be the end of it, as it will head further north and likely weaken as it gets into much colder sea surface temperatures. I can actually zoom out and show you those cooler sea surface temperatures there on the forecast cone there, less than 26 degrees Celsius east of South Korea. Now, this is the GFS ensembles, and what's carrying this system north is this ridge that you see building west into Japan. This has been pretty high confidence since last week. And now something that has changed with the GFS in particular is, remember, the GFS was trying to build ridging all the way across the region all the way into northern China, which had the storm on the model coming back towards Shanghai. The GFS has gone into more agreement with the Europeans since then and has shown more troughing here north of the storm. So this trough coupled with this ridge will allow a nice path northward. Now there is the potential that the system does just hang around as it heads further north. There is going to be some ridging building further north that may keep it in the region. But the good news is this will be in a region of where land is and where much cooler sea surface temperatures are, and the system will likely weaken significantly and not be too strong at all by the time we get into, say, next week, where the storm still might be sitting here, you see on the GFS. And you can see also the same general picture on the European model, with that ridge building in this trough here as well, allowing a path northward, but there being some ridging up north building, which allows the system just to kind of sit here. And it could bring some increased rainfall to portions of South and North Korea and China, as it does sit through there, although the system again should be weakening as it comes over cooler sea surface temperatures. Now, across the, well, this is before I go to the East Pacific, this is the forecast code from the Joint Typhoon Warning Center. You can see they are forecasting the system to become a typhoon again as it comes towards southern Japan and then track further north here. And we could potentially be looking at some tropical storm force winds, potentially upwards of 50 knots here in South Korea and portions of southern Japan, and tropical storm force winds over gale force in portions of North Korea. All right, now moving to the Eastern Pacific. This is Hurricane Dora. The system has been moving across the open Pacific Ocean for the past several days and has had quite an interesting track overall with its intensity mainly. It had now 3 separate occasions where it's become a Category 4. It is now estimated to be a Category 4 again, as you can see the symmetric CDO surrounding a clearing eye there. And this system will continue to track south of the Hawaiian Islands over the next several days. You can see it's just about to the Central Pacific, which is about here at 140 degrees west of longitude, and the forecast has it remaining a hurricane throughout the entire forecast. It does get a bit more uncertain on exactly what may happen once the system gets southwest of the Hawaiian Islands. Some models have shown higher shear. Some models have actually shown more favorable conditions that may allow the system to strengthen maybe a little bit southwest of the Hawaiian Islands, maybe getting towards the Western Pacific where it'll become a typhoon there if it stayed at typhoon or hurricane strength. But overall, no impacts are expected to occur in Hawaii as the system is pretty small. Surf impacts would likely not occur, and the system is forecast to track pretty far south of the Hawaiian Islands this time. So it's not like Calvin where we had to deal with the system coming right our way. The system is tracking pretty far south this time. Now we also have Eugene off the coastline of Mexico here. You can see the general structure is looking pretty good, pretty typical for a tropical storm that you would see forming in the deep tropics with curved band structures or curved bands wrapping around into the inner core, which is just about here. Winds right now are estimated to be about 40 miles per hour, and the system could intensify a little more over the next couple of days as it tracks generally northwest, but the 26-degree isotherm here is still pretty far south, so the system will likely run out of steam pretty quickly, but there might be some adverse impacts brought to coastal areas in Mexico and the Baja California Peninsula. And over the next few days, the system is forecast to track into the cooler seasonal temperatures of the Pacific west of the Baja California Peninsula. And by then, the cooler seasonal temperatures will allow it to really dissipate. And no adverse impacts are forecast for the system to come towards California, as by this time, the system will likely be dissipated by the time it actually goes towards California. All right. That's the tropics discussion for today, but this is, for the rest of this video, this is what we're pretty much going to be looking at. We're going to be looking at primarily the Atlantic hurricane season and what we can expect over the next 3 months, as we are now in August, and the 3 peak months of hurricane activity in the Atlantic is August, September, and October, with the climatological peak being September 10th. And this has really piqued my interest this year because this is such an interesting scenario that we have playing out here. Now, starting off simple, we have an El Nino here that has developed over this past spring and summer across the equatorial Pacific, that being where the waters across the equatorial Pacific are above average. Remember the past 3 years in 2020, 2021, and 2022, we had a La Nina. At times it may have gone more neutral, but in general, we had a La Nina here. And in general, La Ninas are favorable for the Atlantic, and El Ninos are not favorable for the Atlantic because you get a lot of warm water across the Pacific, and that causes a lot of increased convection. You can see here, this is a plot. I went here and got a plot of years from 1950 to 2022, or sorry, to 2020, that had an ENSO 3.4 index, which is in the Central Pacific south of Hawaii, of greater than 1 degree Celsius above normal. And you can see the general normal here having the ENSO positive here of the El Nino, and also the warmer sea surface temperatures in the north of the PDO on the western fringe of North America. And that's typically what you see here, and typically you get lots of rising air here because of the increased convection and a lot of sinking air here. And this rising air allows more easterly winds across the Caribbean, which increases the trade winds. And you can see that in this plot here, showing increased easterly winds across the Caribbean and East Pacific, increased westerly winds across the Western Pacific. And this is different to a La Nina, because in a La Nina you have cooler seasonal temperatures, which means you have less overall convection, and you get westerly anomalies in the Caribbean, slowing down the trades, which makes it more favorable. But in an El Nino, you don't have that. You have this rising air cell over the Pacific and increased easterlies, which increase the trade winds. Alongside that, within the anomalous convection that you typically get across the Pacific, you get the enhanced subtropical jet over the Atlantic, which allows further shear, which makes systems struggle across the Atlantic. Now, note what I said, that you typically have more of a positive PDO signature here of a warm horseshoe of water. And now this anomaly map does not show a real well-defined PDO, but in a lot of these years that you can see at the bottom, there was a pretty well-defined warm horseshoe of water here, and those typically go hand in hand, having a warm PDO with a warm ENSO signature. Now, this year we have the El Nino, and we do have some warm anomalies here off of North America from Alaska down to California. But notice this cold tongue of water relative to normal, stretching from about California down to Hawaii. This is a negative Pacific Meridional Mode, or PMM, and this does make the PDO this year overall negative. And this is important as it draws some questions into could we potentially be seeing this negative mode impact the amount of convection that you normally get within an El Nino? We typically do expect, again, a positive PDO, which would allow anomalous convection here east of Hawaii, which can allow more tropical activity near the Hawaiian Islands. But this year, we've had this negative PDO, and the models are showing that this will stick around for really the peak of the hurricane season, and it already has stuck around for so long. So normally that would draw some questions in, and normally in this scenario we would look towards the Atlantic. What's the Atlantic sea surface temperature anomalies looking like? And this year it is some higher than we have ever seen, as I'm sure you've heard a lot in the news. We can see across the deep tropics the temperature anomalies are very warm. In a lot of cases this year we've had record warm sea surface temperature anomalies in the MDR, that being the region here from the Lesser Antilles all the way to Africa. And you can see also this warm horseshoe of water extending up to south of Greenland. This is a positive AMO look. Now, another interesting feature is this very warm water off the coastline of Canada relative to normal. You can see some of those anomalies are off the charts here. In fact, I looked at some charts that go above 5 Celsius. There are some anomalies here 6 to 7 degrees or more above average off the coastline of Atlantic Canada. Now, normally, this coupled with an El Nino, you'd expect that this would probably lead to a less active Atlantic hurricane season because of the El Nino effects of having the increased shear from the subtropical jet and the increased trace throughout the Caribbean. Alongside that, normally in the Atlantic, what you have is you have a rising cell here with the warm sea surface temperatures in the deep tropics, and then you have all that rising air sinking in the subtropics. But if you have warmer anomalies here off the coastline of Atlantic Canada, you can get increased convection in this region, which can disrupt the normal rising air, sinking air cell that you typically have in the Atlantic. And this has been shown in several years prior to have had an impact on tropical cyclone activity in the Atlantic. Last year, 2022, is an example where we had very warm anomalies here relative to normal off of Atlantic Canada. And that had actually been one of the factors that had suppressed some of the Atlantic activity into August, where we had an entirely quiet August. Another example was 2013. That Atlantic hurricane season also saw very warm anomalies relative to normal off of Atlantic Canada. That also led to a fairly below average, actually not fairly, a very below active season across the Atlantic, and when lots of forecasts were above average. Now, this year, the main question is, will this anomalously warm waters be able to combat the very warm, record warm waters of the MDR and the Atlantic? Alongside that, will the warm waters of the tropical Atlantic be able to fight off the effects of the El Nino? We have not seen an Atlantic this warm, and alongside that, there are not a lot of years prior where we have this warm of an Atlantic and this type of Enso pattern. This type of Enso pattern with an El Nino and a negative PMM, not exactly all too common in reliable records. So it is a pretty difficult year to find analogs, but there are a couple that we can look at that might give us a general idea of what we may see across the Atlantic this year. Now, I'm using the analogs here from CSU, Colorado State University. They have the set years 1951, 1969, 1987, 2004, 2005, 2006, and 2012. Now, I'm not going to be showing you all of those years, but I will show you a select few. This one in particular is 1951, and you can see that this generally has some of the patterns that we have this year in place. It has an El Nino with a negative PMM, and while the Atlantic doesn't exactly seem optimal in this year, if you do change the composite anomaly years from the modern anomaly years, which is 1981 to 2010, to older years, like I've done here, This is from 1920 to 1950. You do see that this matches more with what we've got across the Atlantic, with El Nino here with a negative PMM and a warm tropics across the Atlantic overall. It also has notably the warm waters off of Atlantic Canada. Now, exactly what did this hurricane season do? Well, this is the 1951 Atlantic hurricane season track map from the National Hurricane Center, and you can see it was fairly active, especially for the time. We had 11 storms across the season, a couple of which did go into the Caribbean. In fact, one of those being a major, not typically what you would expect in an El Nino year, but a lot of activity here, and a lot of storms did stay out to sea, which was fortunate, but there also were storms that did get close to land areas here, and that were hurricanes close to land areas. Now, another year that I'm going to show you is 1969. You can see that this also has the cool waters off of Baja California and California, and you can see the El Nino here. And if I backtrack this, getting a different composite, you can see the warmer anomalies of the El Nino with the cooler anomalies here off the coastline of West or North America. Sorry, and you can see the Atlantic is not as optimal overall, but there are some warmer anomalies showing up, making this a fairly decent analog overall. And what happened in this season, it was a pretty active season overall, 18 named storms, and you can see a lot of activity near land areas here, including the infamous Hurricane Camille of that year, which came into Louisiana and Mississippi. Now, another year that I will show you is 2006. If I pull this up, this is 2004, but I want to show you the tropical tract for 2006. This was after 2005, obviously, which was one of the most active hurricane seasons on record. But notice in 2006, we didn't have as much tropical cyclone activity here, with only 10 named storms. That is below average overall, but something I want to point out is look at the concentration of tracks near land here in 2006. Now, a lot of them weren't strong, thankfully, in 2006, but we did have a lot of activity near land, and we also had some activity here in the Caribbean, which is not exactly normal for an El Nino year. And now, overall, the analogs chosen by Colorado State University do have years, a lot of years that were pretty active. Just the average of named storms from all these years that they picked out is about 15.6, which that would round up to about 16 named storms, which that is above average even in today's standards, which the average is about 14 named storms. Now, overall, CSU has looked at these analog years overall, and they've come up with this forecast. I'm sure you've seen this. They released this a couple of days ago, showing 18 named storms. Now, this is on top of our January subtropical system, Arlene, Brett, Cindy, and Dawn. So that's about 5 systems done, so about 13 left from now to the end of the season. 9 hurricanes, which would be 8 and more because Dawn was a hurricane, and 4 of those 8 hurricanes becoming major hurricanes in an accumulated cyclone index of 160. That is very above average. You can see the average is about 123. And ACE is calculated by the strength and duration of a tropical cyclone intensity. So if a system is a category 3 major hurricane for a very short amount of time, it won't have that much ACE. But if it's a category 3 or higher for a very long amount of time, it will have a lot of ACE. And given the current conditions today that we see in the sea surface temperature plot, and given some of these analogs with a lot of tropical cyclone activity here, stretching from, say, Africa all the way into the central and northwest Atlantic, it makes sense that you would potentially see some long tracking hurricanes here, like you can see in 1951. And those could potentially be bringing up those ACE points. That's a good metric to see exactly how active a hurricane season was, apart from named storms, because you can sometimes just get very weak storms in the subtropics that don't do much. Now, if I were to put out a forecast, given the current expectations here of the analog years and the current sea surface temperature plot, I would probably go a little bit above average, say overall, including all the storms we've had so far, which would be 5, I'd say something along the lines of CSU, maybe a bit lower, seems about right here. I think the odds that we have a normal to above average season are pretty high here. I'd say we really have to see exactly how the Atlantic plays out with the El Nino to say exactly how active it's going to be. I know there's been a lot of forecasts that have come out over the summer that have been very active, showing activity levels that have been similar to 2021. Now, it is possible that we get that high given the warm Atlantic, but I would say that generally the most likely scenario is that we have an above to above average hurricane season, because we do have to still consider that there is an El Nino here. This is forecast to strengthen, and that will still bring some impacts to the Atlantic, especially once we get some bigger hurricane activity like we've seen in the East Pacific now with Dora and Eugene. It's going to be a very interesting seasonal forecast, but of course, regardless of what I've said here regarding anything of the Atlantic hurricane season, even if this season turns out to be below average overall, it is important to note that it only takes one hurricane or even not even a hurricane, it only takes one tropical cyclone to make a season historic. You don't need a hurricane, and you don't need an extremely active hurricane season to make a season historic. There have been countless examples of this. Last year's an example of not really a too active hurricane season. In terms of ACE, that season was actually below average overall. And we had Fiona and Ian last year. Very, very significant storms that made that season historic despite the near to below average activity that we saw last year. So that's very important to point out. Just wanted to make that very clear. Now, that's all that I've got to talk about. I'll probably have future videos talking about stuff like this, maybe for other basins later this month, maybe more about the Atlantic and how we're progressing later in the month and into September as we get through the peak of hurricane season. And of course, I'm going to have videos on our tropical systems currently active now, and that will be active in the future as we are getting towards the peak of hurricane season. Final recommendation, as it is August the 5th, as I'm recording this in the US, we have some time here where the Atlantic is still a bit quiet across really everywhere. The tropics are still pretty stable right now for tropical cyclone development, and we're not really expecting any big storms to form in the next 7 days. And really, we're looking at maybe the season starting to kick up mid to late August. So this is a time to get your hurricane plan ready. If you have not done that yet, do it now. It's not guaranteed, of course, that you're going to get hit by a hurricane. The chances are relatively low overall for your exact area to get hit, but it's always good to be ready just in case that scenario does occur. And of course, stay tuned to the National Hurricane Center website. They're going to have the best information ahead of any tropical cyclone formation, and they'll have the best forecasts out ahead of what you can do. And stay tuned to your local National Weather Service office as well, as they'll have information ahead of the storm of what you can do and prepare if the storm does indeed come your way. But that's it for now. Thanks for watching.